Hello, my name is Malvika Gupta, and the topic we are going to discuss today is limitations and applications of an array. So we all know that how useful array as a data structure is. But now we need to discuss that apart from the application areas, what are the limitations we face as a user when we are using this data structure. So before moving ahead into this topic, let me go through the contents which I am going to cover during this lecture. So it will be limitations of an array because our topic is limitation and applications of an array. So I'm going to discuss about the certain limitations. May be possible that you will be finding it like a contradictory that whatever is we are considering as the positive aspect of an array, it might be considered as the limitation also of an array. Secondly, I will be taking an example on by running because certain things are there which we need to understand that yes, this is the point. This is how we have implemented this array, but how these things are like maybe considered as the limitation also, right? So I will be running some codes for you just to make you understand that yes, this is how the limitations can be considered, right? The last one will be the application areas where the array is used. I know you all must be knowing all these application areas, but we will be focusing about it also that all these are the application areas. So now let's start the lecture with the limitations of array. So the first point is the homogeneous data. Homogeneous, we all know it's a similar data. We all know the definition of array. The basic definition of an array is it is a collection of similar type of data referenced under one name. This is the basic definition which we have studied throughout our engineering or our schooling, right, in the programming languages. But if you see that homogeneous type of data, it means let's suppose if I have written it like this, that I wanted to store the marks of all 60 students in my class. So it will be like I will be writing it like this. So it shows that I know that marks will be of integer type. So naturally, all the 60 students have integer type of marks. So I have made it like this, right? I can store my marks over here. But what does it mean? It is helpful because array has the property that it will design it will give you a contiguous memory allocation. Contiguous memory allocation means that you can access each element one by one. You are not supposed to access it randomly. So because random access will take little bit more time as compared to the contiguous allocation, but it is much more easier if you have access the first zeroth location and zeroth index value, then you can access first index, then you can access the second index, and we all know that how this accessing works, right? But now if you see, if I have to give you a scenario, array is a data structures which is very important for the storage, and so many things we have done with the help of this array data structure. But now the question arises that how I will be taking care that the marks of this student is this much, because I have stored all the 60 marks. Only the 60 marks I have stored. I have not provided the roll number. I have not provided the name of that particular student. So how I am going to differentiate that this marks is for this particular student and this marks are for this student, right? So this is a problem with array because it is not having the heterogeneous type of data. It cannot store. It can only store homogeneous type of data. So this might be a limitation for an array, that it can store the data, but it can store only the similar type of data. So we need a data structure that most of the time which can store the heterogeneous type of data. Because suppose if I wanted to store the marks of a student, then I always wanted a data to be like this, a sheet to be like this. There's a roll number, there has to be some name and the marks of that student. This is the complete information which I wanted to store with me, so that whenever somebody asks me that what is the marks of this particular student, so I will be taking out, okay, this is the sheet and these are the marks of this particular student. But if suppose I have nothing like this roll number and name written with me, I was just having I was just having the marks. So what will happen if somebody asks me what are the marks of student X? How I'm going to justify that these are the marks, because all those 60 marks are stored in a list. That's it, right? So this could be a problem, a limitation with an array. So for this reason, for this, how it can be, I just wanted to explain you this through a code. Suppose this is a C code because I am going to test it, so you know that, right? So I am writing it in the C language. So you just need to focus on that. This is the same thing will happen with the C++ and Java. So I am just considering only the C language, right? So I am declaring an array of 10 elements and I. A loop variable I am taking for I equals to 0. I is less than 5. Suppose I wanted to store 5 values, I plus plus, and then scanf. Oh, I'm scanning these values. We all know how to scan the data in an array. For I wanted to print it, so I'm taking I equals to 0, I is less than. I'm not beautifying it by writing everything. So you just understand that this first loop is for the input and the second loop is for the printing of the value. So printf, I'm just giving is %d slash n, and then I'm writing a of I. Okay. So now my point is, because I have declared this array as an integer type, now you understand this concept that array you have considered, you have declared as the integer type. It means it can only contain the integer type of data. What will happen if I provide some character type of data in this? So let's see, let's run this program and then we'll come to know that what will happen. So suppose I have provided 1 and the next value I have given w. Now you can see that the answer, it is not displaying the exact, it is not even taking all the 5 values. It has stopped working and it is giving me some garbage values, which I have not entered. 1 is okay, 0, W, some garbage value is coming. So it is not the exact output, expected output, which I was expecting, right? Now, if you see, if I am giving all the integer values, then what will happen? 1, 2, 3, 4, 5. Now you see, it has taken all those 5 values as input and then displayed all those values. So this could be a limitation. If I wanted to store certain data, if I wanted to store the data, then it has to be there that we can store the data in the perfect order or perfect things. Like if I wanted to store the marks, then it should be like roll number, name, and marks. So this could be our limitation for an array. Next thing is this, that passing array size is mandatory, because we are considering about the C language. So I am telling you that passing array size is mandatory. It means that if I have written it like this, if I have declared an array, so the array size should be array size should be declared first. It is a kind of a compile time declaration, or you can say static allocation. As we all know, array is a static allocation. Now what will happen? It might cost you the shortage of memory or wastage of memory. It might be a reason for these two things, right? How it is a wastage of memory. If you see, if I'll take you to this particular example, you can see this, that I have taken an array of 10 size, right? It is of 10 size. Now 10 and the integer size. So it means 10 blocks, each of integer size will occupy 40 bytes at the time of compilation, right? Now what happened? When I was entering the data, I have just used only the 5 blocks. So what happened? 5 into 4 is equal to 20 bytes. Now you see, 20 bytes got wasted because I cannot use those 20 bytes for any other reason. I have to use it for under this number, this name only, referenced under one name. That is why it is always written over here. So you see this, 20 bytes I have used, but what about the rest of the 20 bytes? It all got wasted, right? So same thing. And what will happen if suppose I wanted to store 11? So according to the practically speaking, it can only hold 10 blocks. It cannot hold 11 element. If you are going to ask for the 11th element, it will show an unexpected result. So this is the problem with an array, that when you are passing the array size at the starting, so you never know, user, it might be a possibility that user can just wanted to store more elements as you have decided, or maybe it user wanted to store less number of elements as you have decided as a programmer, right? Now the third point is, it does not check the boundaries. Now what does it mean? Because we have already said this, that it could be a possibility that if the boundary has been decided with 10, so it is not possible that it can store 11th element. But there is a condition in C language that when we are using the concept of array, it will not see the boundaries. It does not check the boundaries, and that's why it may lead for some unexpected results. This we can see through another examples. Suppose if I am taking this particular section, I am just putting a comment over here so that it will be easy for me to make you understand. See, I have created an array of 10 size. Now what I am going to do, I am just going to do I equals to 0, I is less than 20. Okay, it is more than the defined size, right? And what I'm going to do, a of I'm going to store I over here, right? Now you see what values we are expecting. Now, if I run the loop from I equals to 0, I is less than 20, I plus plus. So what exactly is expected? It is expected that it should not take values beyond 10. But let's see what will happen. You need to check it out, right? So I'm just writing %d because it is an integer array. Slash and I'm taking, and then here I am taking a of I. Okay, fine. So before going ahead, let me give slash and over here also, multiple slashes, so that it can give you the maximum space. Now let's run this one. So we have expected that we have already designed an array which is having 10 maximum size. Okay, and after 10 it should not take any 11th number also. But here if you see, I have made an array of 0 to 20. So let's see how it will work, right? So now you can see from here, it is giving me the values from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 up to 19. Can you imagine? So this is the condition. This could be a limitation in C language, that it never checks for the boundaries. It can go beyond boundaries also. So out of bound exception is not present most of the times in C language. It could be a limitation of in an array, right? So Nasi, practically it should stop till here, till 9. It should not go beyond this one, but it is going till 19. So this is the third point. This is the point which we are discussing, that it does not check the boundaries. I hope this is all clear to you, right? The next thing, the last and the most important, because whenever you are considering array, as because array is a linear data structure, so when we are discussing about the linear data structure, there's another name which comes into our mind. It's linked list. Then the second point which comes into our mind, strikes to our mind, is how array is different from linked list, how linked list is different from array, where we have to use array, where we have to use linked list, and how efficient using array in certain situations, or how efficient it is to use linked list in certain situations. So that's we need to discuss. If I take the condition of this insertion and deletion in an array, we all know that how the insertion happens in an array, and we know how deletion happens. If suppose this is 3, 4, 5, this is the array I have been given. Suppose, okay, my array size is, suppose I am taking it as 10. So I have lots and lots of array present with me. So I'm just making it the dynamic size array, 6, 7, 8, and 9. This is a dynamic, this is a static array I have already created, because a of 10 I have taken. So this is 10 size of an array has been created. So from those 10, I have only utilized this 5. Now I wanted to insert 6 at suppose position 2. So what will happen? Now see, it will shift this 5 to this position, this 4 to this position, this 3 to this position, and then it will insert 6 over here. So it will be like this, right? It means you have to go for order of n times. You have to search till that particular position, and you have to make the shifts, right, to insert that particular element. If suppose, now the question again, you may ask this question also, that ma'am, if suppose we wanted to insert this at the last position, so then what will happen? 1, 2, 3, 4, 5, and this is the position 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. If suppose you are going to ask me this question, that ma'am, if suppose we are going to insert this element at the last position, then also you have to do, you will be traversing through this one. You will be writing an plus 1, right? An minus 1, an at the an position. Again, you will be here. So you'll be traversing all the n elements, right? So this is the problem with array. It will take order of n time. Whereas if you see in the linked list, in linked list, you just have to make certain arrangement. If suppose I wanted to insert an element in between, a node in between these two, so what I have to do, I have to just connect here from here and here from here. So it will take order of 1 time in the connection, right? So it will not create a problem for me. That is why when insertion is happening, so we consider array is no doubt a very easy and simpler in concept, but if time is a restriction and if we need more time or if we need time efficient algorithm, then we always prefer to have linked list. Same is the way with the deletion. If suppose I wanted to delete this 2, so what will happen? We have to shift one position ahead each element. Again, we are taking order of n time. Whereas in linked list, if I wanted to delete this particular node, suppose I just need to put null over here, order of one time, no point, nothing I have to do. I just have to go there, put a null, so it will be done, right? Okay, fine. I hope it is understandable to everyone that how it is different from how array has, how much limitations array is having, where we can use linked list if we have some time efficiency required, then we prefer to use linked list in respective of array. But otherwise, array is a data structure which holds maximum and can store the large amount of data also, right? Now let's focus. Let's go to the next point, which is applications of an array. We know we have already used this you might have used the concept. So this is the data structure. Array is a linear data structure. When we are using this data structure, not primitive sort of data structure, then we are using the concept of array in stacks and queues. It is required and it is very helpful in implementing stacks and queues using arrays, right? Some lookup tables in computers also is there. There is an array stored, array has been created and all the locations or all the values have been stored in that array. And when you wanted to search for something, then you just need to go for that lookup table and from there we can access our positions or our locations easily, right? CPU scheduling. We know that CPU scheduling is a very important topic of the operating system. We know that CPU always works according to the schedule. Whatever is the scheduling process, we are going to use an algorithm like if we are going to use SJF, if we are using round robin, or we are using FCFS, any of the scheduling algorithm, whatever we are going to use, we use the concept of array. All the processes are stored in an array, and according to the scheduling algorithm, we are removing these processes, we are processing, we are operating, enabling or activating these processes, or we are deactivating these processes. So it is very helpful in the CPU scheduling. Next is, because with the help of array, we have a 2D concept also. We can create matrices, we can solve the problems of mathematical problems like matrix problem using the arrays. 2D array, we can use the concept as. And then in computer graphics, because you know that we have an image, and in computers there is no other data structure which can help us out to store the pixel values or to perform certain manipulation on a particular area of a pixel using any other data structure. We don't have any data structure like this. So we only have a 2D matrix, or you can say 2D array present with us, through which we can hold the pixel values, the coordinates, and then we can perform some manipulations on the images. So this is all about the application areas. And in daily life, in day-to-day life, we are using arrays in most of the cases. Most of the time we are storing, like suppose storage of marks only. If I wanted to store a marks, if suppose I wanted to have the roll number list of my class, so what I am going to do, I'm not bothered about the name and marks and the previous semester results or previous year results. I'm just only concerned about that this is the roll number 1 to 60 for section A, this is 61 to 120 for section B, and so on. So I just wanted that roll number list. So for that reason also I can use this array. And most importantly, because array is providing you the contiguous allocation, so it will be very helpful for you to perform contiguous allocation. And if you wanted to search, array is the most preferred data structure that we use for the searching techniques. So that's all for this topic, limitations and applications of array. If you wanted to go through, you can use these references. These are the books which you can refer for your more understanding. And thank you. That's all from my side. Thank you.